All right, geometry OST review topic 11 on 2 and 3-dimensional figures, models. So there are lots of these on the formula sheet, right? So, and they actually do like this on the state test. They focus more on the circular figures, so cylinders, cones, spheres, but for some reason they want you to do this. Now, a lot of times it's not about figuring out the volume, but it's more or less finding the height or finding the radius. So you got to be able to solve an algebraic equation. Okay. So let's go over a couple things here. Let me scroll down just a smidge so we can talk. So first off, Euler's formula, don't have to know that. Okay, not a big deal. Cross sections. So this is where a 2D plane, right, intersects a 3D solid. So there's just a couple things you have to remember here. Okay. So So first off, okay, ignore this right here. So if you are a prism, remember that a prism has two congruent bases. If you're going to be a cross section or a plane that goes parallel to your bases, then your cross section shape is going to equal the shape of the base. So for instance, if you have a cylinder over here and your plane goes parallel, it's going to have the shape of a circle. But if you go perpendicular to the base, then you're going to have the shape of a rectangle. Because in a prism, the lateral faces are rectangles. So again, if you go perpendicular to the base, now you're this thing. And that's going to be a rectangle. Again, I know it's slanted, but it's because it's a 3D figure on a 2D space. Now the other shape are pyramids, right? So pyramids. So for a pyramid, you have one base. So say we're a cone, right? If we are parallel to the base, then we'll equal the shape of the base. So again, if my plane cuts it that way, then you're going to be a circle, right? Circular equal to the base. But now if you're perpendicular to the base in a pyramid, now when I go through this point, so now you're going to see that it forms this triangle. So now you're a triangle, right? Because a pyramid, because it comes to a point, has the top point. So its lateral faces are triangles. So you can keep those in mind when you talk about cross sections. Okay. And then last but not least, very important, rotations of polygons. Right. So this is where you take a 2D figure and you rotate it about a line to create a 3D figure. So there's only three you have to remember. So first of all, this is my line that I'm rotating about. If I start with a rectangle, and I rotate it about this line, those points are going to go there. Those points go there. You connect the dots. Now you have a cylinder. Okay. Say I have this line and I start with a triangle, right? Again, I rotate it. So if I have a triangle, these points will go here, these points will go there, connect them. Now you have a cone. And then last but not least, here's my line of reflection, my line of rotation. Say I start with a half circle. So half of a circle. When I rotate, all these points go over here, connect that. That's a terrible connection. Now you have a sphere. Okay, so again, when you do a rotation of a 2D figure, you're going to create something with a circle in it. And that would be a 3D figure involving a circle, a cylinder, a cone, or a sphere. Okay, so that was the intro to your 3D and 2D figures. So now let's talk about volumes. So first of all, this idea of Cavaliere's principle. Big idea here. So if two figures have the same height and same cross-sectional area, then they'll have the same volume. So if we look at these two prisms here, we have a rectangular prism and a triangular prism. So they're trying to tell you that both of these shapes have a base area of 30, which is true. So this capital B stands for base area. Area of the base, capital B. So their cross-sectional area is equal. They also both have a height of 14. Therefore, these two volumes will be equal. They'll have equal volumes by Cavaliere's principle. Okay. Again, this V equals BH is on the state test reference sheet. Also, the cylinder formula, pi r squared h, is on there. And again, the area of the base is just the shape of the base. So if it's square, rectangle, triangle, there you go. And this is just for a circle. Pyramids and cones, again, this formula is on the reference sheet. 1/3 area of the base times the height. And again, you also have the one for the cone with the pi r squared involved. Remember, you have to have the vertical height They cannot give you this slant height. Typically, they call it L. I don't think they will, but you do need this vertical height. Maybe they'll give you both, and you have to pick the correct one. Make sure you use this one. And then last but not least, you have spheres. Again, we can ignore all of this. The volume formula for a sphere, which is on the state test reference sheet, 4/3 pi r cubed, right? Don't forget about that cubed. And again, if you have to solve for the radius, remember you have to take the cube root. And I showed you in the video how to take the cube root in the graphing calculator. That's how you get the cubed to cancel. All right, and there's topic 11.